Good day, viewers all over the world. Today, we want to look at the first method that we can use to find a particular solution of non-homogeneous differential equations. And the method is the method of undetermined coefficients. So the method of undetermined coefficient is applicable only if phi of x is the right-hand side. Only if the right-hand side and all its derivatives can be written in terms of same finite set of linearly independent functions, which is denoted by, that is, we can only apply this method of undetermined coefficient if the right hand side of the non-homogeneous linear non-homogeneous differential equations can be written in terms of the same finitely set of linearly independent functions. So if you can write it in this one, then that's the only time we can apply this method of undetermined coefficients. And there are three cases involved. Case one, if the right-hand side, phi of x, is a form of polynomial p subscript n of x, that is an nth degree polynomial in x. So we assume a solution of this form. So if y of p is, say, degree 2, then we have x squared plus something x plus constant. Okay? Then case 2, if the right-hand side is a form of exponential, k exponential alpha x, where k and alpha are constant, we assume this solution for the particular solution. And the third case is when phi of x, that is right-hand side, is a form of k1 sine bx plus k2 cos bx, that is a form of a trigonometric function, where k1, k2, and beta are non-constant. Then we assume this solution when we have it in the form of trig. This exponential, this trig, then this polynomial, and that is polynomial. So, but we must note, let's take note, we have to take note of the following. We must note, the first thing that we have to note is that if phi of x, that is the right-hand side, is the product of terms considered in cases 1 through 3, then we take that particular solution, y of p, to be the product of the corresponding assumed solution and algebraically combined, arbitrarily where possible. That is, if we have combination, that is what we are trying to say is that if in a situation whereby we have combination of two or more functions, how do we write the particular solution? That's what we are about to do. So let's take note. If phi of x is actually talking about the right-hand side of non-homogeneous differential equations. So if phi of x is given as, say, e alpha x, then pn of x. In this case, we have product of exponential and polynomial function. So how do we write the particular solution? So the particular solution will be written as phi of p will not be exponential alpha x into bracket, we have to be an sn plus an minus 1 sn minus 1 plus dot 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 plus ax plus a naught. So this is how we write it. In this case now, the right-hand side, phi of x is talking about the right-hand side if it's a product of two functions. So how do we write it? That is how it will be written, and that is what we are trying to say. Then another condition is that if any of the term of the assumed solution disagreeing multiplicative constant is also a term in y of c, then the assumed solution must be modified by multiplying it by x raised power n, where m is the smallest integers. That is, if in a situation whereby we have in case of the general solution is y of c plus y of p, we must have gotten this before we can go ahead and find y of p. So we write for y of p in form of the result that we got here. So if any of the solution here has a form here, there's a way we write it. But I'm going to use example to show that. So let's consider the first example. Example, let's say example 1. Here we are asked to solve example 1. The question says solve y prime prime plus y prime, no, minus y prime minus y minus 2y is equal to 4x squared. Okay, so let's look at this question. Let's look at this question. In this case now, you realize that this is non-homogeneous. Why is it non-homogeneous? Because the right-hand side is not equal to 0. So this is non-homogeneous. Why is it non-homogeneous? Because the right-hand side is not equal to 0. So what do? We go ahead and find it. We cannot solve this directly. We first solve the complementary solution. That is, we assume the right-hand side to be 0. We get the value of complementary solution. Then before we go ahead and find a particular solution. That is, we say the complementary equation. So let me first rewrite this. That is, we first find y prime prime minus y prime minus 2y equal to 0. That's what the first thing to do. We assume the right-hand side to be equal to 0 in order to find the complementary solution. So once we get the complementary solution, we can go ahead and find the particular solution. That is how to solve this type of problem. So what is the characteristics equation of this problem? The characteristic equation will be m squared minus m plus 2 m minus 2 equal to 0. So can we factorize this? Can we factorize what we have on the board? Yes. We say this is m squared minus 2m plus m minus 2 equal to 0. Then m is common here. We have m minus 2. Plus 1 is common here. We have m minus 2 equal to 0. So we say m plus 1 or m minus 2 equals 0. So m plus 1 equals 0 or m minus 2 equals 0. So m is equal to minus 1 or 2. These are the two values of m. So we have gotten the value of m. And of course, since we know the value of m, we can go ahead and write the result of complementary solution. The complementary solution will just be c1 exponential minus x plus c2 exponential 2x. So this is the complementary solution. We have gotten the complementary solution. How do we get the complementary solution? We assume the right-hand side to be equal to 0. So once we know the complementary solution, we now go ahead and find the particular solution. So in this case now, phi of x, which is right-hand side, is given as what? 4x squared. So because this one is a form of polynomial, then our y of p will be assumed as the highest degree is x squared. So we are going to have something of ax squared plus bx plus c. That's how we write it. Don't you see? When this is the example under the case 1. This is example under case 1. So that's how we are going to write it. This is example under case 1. And of course, we have y prime here. We have y prime here. So we go ahead and find y prime of p. When we differentiate this, we have 2ax plus b. Then we differentiate the second time, y prime of p. That will be 2a. So what do we now do? We now substitute. We go ahead and substitute all these values back into this equation. That is what we do. We substitute the value. We substitute all these results back into this equation. No, we have gotten the particular solution. So let's take note. We have gotten the particular solution. We have gotten the particular solution. Then how do we get? We have gotten the complementary solution. How do we get the particular solution? If the highest degree here is 3, y prime, we go ahead and find y prime of p. But this is what we have. Now we now want to substitute this into the solution. Of course, what do we have there? We have y prime minus y prime minus 2y is equal to 4x squared. So I want to clean it so that I'll be able to substitute correctly. Okay. So what do I do here? Please let's look at it. What do I do here? So where I have y prime, I'm going to substitute this. Where I have y prime. So I will substitute this now. Instead of y prime, what is y prime? This is 2a. I will say this is 2a minus into bracket. Instead of y prime, I'm going to substitute this to this. I'll substitute y prime of p. I'll substitute it here. That minus 2a x plus b. Then minus, this is 2 minus 2 into bracket. This is y. I'll substitute for y. Ax squared plus bx plus c is equal to 4x squared. So that is what we are going to get. Then I will now open up. Once I'm able to find the value of a, b, and c, then that will represent the solution. So here I'm going to have 2a minus, I can open up directly, 2ax minus b minus 2as squared minus 2bx minus 2c is equal to 4s squared. So I want to collect the like terms here. S squared, though I will have minus 2as squared minus, I want to, that of a minus 2a, I've picked this, then minus, that's plus 2b, okay? Then I'll go to the constant, plus 2a minus b minus 2c is equal to 4s squared. So how do I solve this? How do I solve this? I will consider the coefficients. In order to solve this, I will consider the coefficients. When I have s squared, I want to compare the coefficients now. What is the coefficient of s squared here? It is minus 2a. At the right hand side, what's the coefficient of s squared? That is 4. 4. I will divide both sides by minus 2. Minus 2. This will take care of this. Therefore, a is equal to minus 2. I've gotten the value of a. So I've gotten the value of a. Then I'll go to x. I'll go to x. What is the coefficient of, this will be x. What's the coefficient of x here? That will be minus 2a minus plus 2b is equal to, what's the coefficient of x here? Is 0. The coefficient of x at the right hand side is 0. But I know the value of a. I know the value of a to be minus 2. So I'm going to have this to be minus 2 into brackets. A is minus 2. A is minus 2. So minus 2 times a, that's minus 4, plus 2b equal to 0. Okay. Here I'm going to have 8 minus 2b is equal to 0. So that this implies that 8 is equal to 2b. Therefore, b is equal to 4. So that's what we are going to get there. That's what we are going to, that's enough. There's no 2 here. This will just give us minus 4 plus 2b. This is just minus. There's no a here. So here a will be 4 minus 2b. So here I'm going to get 4 minus 2b. B, here b will be equal to 2. B will be equal to 2. We got the value of b. We go to the constant, the one without x. So we have 2a minus b minus 2c equal to 0. The value of constant at the right hand side is equal to 0. So if that is the case, then what do we do here? What is a? A is minus 2. So minus that, this will be minus 4. B is 2. This will be minus 6. It's equal to, I can transfer this. That will be 2c. Okay? That will be 2c. B is equal to 2. So 2. So at the end of the day, this implies that minus 6 is equal to 2c. Then c is equal to 3. Is equal to minus 3. So we have gotten the value of a to be equal to minus 2, b to be equal to this, then c to be equal to minus 3. So we have gotten the three values. The value of a, b, and c. Since we have gotten the value of the 3 now, then how do we now find the particular solution? Of course, once we substitute back to the equation, we use comparing coefficients. We are going to compare the coefficients. Where yes, the value of coefficient of x squared here, you compare it with right hand side. Where the coefficient of x here, you compare it with right hand side. Then coefficient of the constant, we compare it with right hand side. So once we do that, you should be able to get the value of a, b, and c, and that's what we have gotten. So we go back to where we started from. What is y of p? The particular solution is assumed as what? Y subscript p is we assume to be a squared plus bx plus c. So we have got the value of a to be minus 2. So we say this is minus 2x, b is 2 plus 2x, then c is minus 3, minus 3. So this will represent the particular solution using method of undetermined coefficients. So this represents the particular solution. So what will now be the general solution? The general solution to that problem is yc plus yp. Then this is our particular solution. What about the complementary solution? We have gotten the value of complementary solution to be c1e minus x plus c2 e2x. So what will now be the final solution? Y. The final solution to this non-homogeneous equation will now be yc plus yp, and that will be c1 e minus 2 minus x plus c2 e2x plus the particular solution, which is given as minus 2 minus 2x squared plus 2x minus 3. That will be the general solution. So if you are given non-homogeneous differential equations, you'll be required to find a particular solution and the complementary solution. So at the addition of the two will give us the final solution as we have gotten it here. Thank you.